Hello, families. I just wanted to do a video on the test answers, just because we would go through them in class, but just in case a kid still is just a little bit misunderstanding some questions, it's better to have a video of it so that you can at least go look at it yourself and help explain. Or if you're the kiddo watching this, I hope that this kind of jogs your memory as to what we talked about during class. So this is for the Chapter 5 post-assessment. These are going to be the correct answers so that you can fill out the reflection form that went home today for class. So, also want to apologize for my voice. Super nasally right now. I'm losing my voice as well. I did not take my allergy meds this past week, especially after all the yard work, so I am struggling. All right, let's get into it. So for A, which is right here, I'm circling on the screen, we need to draw a polygon, and a polygon is a closed shape with straight lines that has at least 3 sides. But we need to draw this polygon with exactly 2 lines of symmetry, and then we need to label those. So I'm first going to go ahead and make my lines of symmetry, and then from the jump, I'm going to label those LOS, all right, lines of symmetry, just so I don't forget to do that at the end. There are 2 shapes you could draw right here. I'll draw the first in blue and the second in purple. So for the first shape, all right, that we have learned about, it is a rectangle. As you can see, rectangles here have 2 lines of symmetry so that if it is folded, it reflects perfectly. And then the second shape that we have learned about is right here. And as you guys can see, when I'm folding this one right here, we can fold it perfectly, both hot dog, hamburger. And so that does have 2 lines of symmetry. For B, we need to make a triangle, so a 3-sided figure. And then we need to label the angles as acute, obtuse, or right. All right, so let's start with my 1 line. All right, let's make this a right triangle. So I'm going to go ahead and finish my triangle here. And then I'm going to go through and I'm going to label this. All right. So by putting this square in the corner, I am showing this is a right angle. I've got my 2 marks to show there's angles there in the corner. And these are going to be listed as acute angles. So, important not to forget, all right? I'm going to circle them as I talk about it. Acute is angles that are over 0 degrees but less than 90. Obtuse is angles that are more than 90 but less than 180. And then right angles are exactly 90 degrees every single time. C, polygon with 4 sides. All right, and 1 obtuse angle. So kind of what we talked about in class when going over something like this. When it gives you a set amount of sides and angles that you need to meet, I've always found it easiest to start with that angle. All right, and so right here you can see we start with an obtuse angle right from the jump. And we have labeled that angle now. And so here, my friends, I'm just going to go ahead and finish it. So we have a polygon, 4 sides, 1 obtuse angle right there, and we've labeled it. Here we need 3 line segments. So this is just 3 lines. All right, this is not a shape. This is just 3 lines of different lengths, all parallel. There we go. 3 line segments. All of them are different lengths. All of them are parallel. Here we need a polygon with at least 2 sides that are perpendicular to each other. And then we need to label 1 pair of sides that is perpendicular. So let's start with that. Perpendicular means that the sides are going to come together and form a 90-degree angle, all right? So we can put perpendicular sides, PS. And then here, all right, let's just have fun with it. So here we have a polygon with at least two sides, all right? So we've got our two sides perpendicular to each other. As you can see, we have that right here. And then we labeled that. Boom. For our next one, right, a pentagon, which is a five-sided figure that has exactly one line of symmetry. So I'm going to draw a pentagon that I saw that was very popular. Okay. And with this, we are going to add our line of symmetry. All right. So, this one, it would not, what's the words I'm looking for? This would not be the only type of pentagon that we can draw, all right? What you can also draw for a pentagon, just another five-sided figure, all right? If you want to get crazy with it, let's add our line of symmetry back in. All right, is you could make it kind of look like a house, all right? And that is, that's what I explained during class, just because I found that when students are looking at straight sides, it is much easier to kind of explain that right here and right here are parallel to each other. And so that when we fold it across this red line, that those straight sides are going to match up. And so for fourth grade, this is kind of the preferred example. But if you have a different five-sided figure, different pentagon, then that could also work. I just want to make sure that the students do understand kind of what symmetry means. All right, so for this page, we needed to use a protractor, all right? And the protractors are here at school. So with that, you know, the students place the dot of the protractor right here, and then they follow this line to see where it ends up. This one was 30 degrees. All right. So I'll kind of draw this line here, and I'll explain why I'm drawing it like that. I know this is not perfect. I apologize. But if we imagine that this line is 90 degrees, we know that this is 30 because this line, right, is clearly less than 90. All right, so it's less than 90 degrees. When we draw or sketch a angle that measures 50 degrees, right, I have my protractor on the screen. You're not going to be able to see it because I'm screen recording, but I am just kind of tracing this, all right? So hopefully it does not interfere too much. So I'm going to start with my baseline, all right? I have a single ray, which is a point with a line. I'm going to mark 50 degrees. I'm then going to just connect the dots. I'm going to label this as an angle at 50 degrees. All right. So that is how we draw angles. All right, we're going to work more with that here. But just basically that is the correct answer, sketching it. For number 4, you could have done this two different ways. All right, you could have actually measured angle C, or we could have done subtraction. All right, and I'll tell you why it's subtraction. So in the question, it tells us that Tom sketched a straight angle, which is this right here. A straight angle is worth 180 degrees, all right, because it is a straight line, so it's flat. Then he divided, which means he split up his straight angle into two smaller angles, B and C, which you can see right here. All right. Angle B is worth 45. We do not know what angle C is, and so we need to find out what it is. So what we know is that if we add angle B and C up, we get what this straight angle is, 180 degrees. So in order to find what angle C is, I need to subtract what angle B is. All right, so I'm going to bring that up here. Subtract. From here, I just use my basic math to get 135 degrees. All right. So for this, I have this one pre-typed, but I'm just going to explain it a little bit further here in detail for each of these. So for this question, all right, it starts off with a Venn diagram, all right? And what the students know is that Venn diagrams are used to compare and contrast things, all right? When the shapes overlap, that means that they have attributes from both of the sides, all right? So Kelly has sorted a collection of shapes and labeled them, and we need to take a good look to answer the questions below. In this circle here, we have two pairs of parallel sides. In this side, we have at least one right angle. So in the middle here, we have at least two pairs of parallel sides and one right angle. For A, do we agree? Why or why not? So this was a 2-point question, so we need to answer both parts. Right now, yes. All right, we do agree. The reason is that each section is filled with shapes that meet those requirements, right? So in this section right here, these shapes all have two pairs of parallel sides. In this section, each of these shapes has at least one right angle. And then right here in the middle, well, we got two pairs of parallel sides and one right angle. So yes, everything is checked out. Question B. Why are there two shapes in the middle where the groups overlap? Well, that is because they have both parallel sides and one right angle. Question C. Kelly says that he cannot put a right triangle in either groups. Do we agree? We need to explain. Well, in our groups, all right, let's just go back up to that. We have parallel sides. Well, triangles, all right, as we know, are three-sided figures. So none of the sides can be parallel. But it's a specific triangle here, a right triangle, which tells us that there's a right angle in the corner. All right, so that would be able to fall under at least one right angle. All right, so that is what we're going to need to explain. For no, we do not agree because a right triangle has a right angle. Boom. For D, all right, this one tripped a lot of people up, and that's okay. All right, we're still working on classifying shapes, and this is just a good exercise. All right, so we need to follow these instructions to color the shapes in the collection. First requirement, we need to have all quadrilaterals that are not parallelograms, and we need to color them green. All right. So for the definition of a parallelogram, all right, this could be where some kids got messed up. Parallelograms have two pairs of parallel sides. All right, so we need to color every shape green that does not have two pairs of parallel sides. Well, right out of the gate, we cannot include any of these, right? Because it literally tells us there's two pairs of parallel sides. And show every shape on this side does not fall into that category. All right, so that's why that is green. For our next one, we need to find a trapezoid, and we need to color it purple. So trapezoids have a set, all right, so one pair of parallel sides. So again, we cannot go back to this side. Right here, right? No parallel sides, no parallel sides, On this one, though, right, we have a pair of parallel sides right there and right here, right? So we're going to be able to circle this purple. When I go back down to my last coloring section, I need to find all parallelograms and color them red. Well, that is going to be the rest of these because all of these shapes have two pairs of parallel sides. And that is the answer for D. So I'm going to keep it moving. If you need to pause, that is okay. All right, area and perimeter. So this threw a few curveballs at some kids, and that's all right. That's all right. We're still having issues distinguishing between area and perimeter. Area is multiplication for the inside. Perimeter is addition for the outside. All right, and we'll discuss that here. So how do we find the formula for this area of a rectangle? Well, it is length times width. All right. So here we got 35 times 6. 6 times 5 is 30. 6 times 30 is 180. All right. And so here we just add them up. You're going to get the answer of 210. But we're not done. Tells us to label them correctly. Inches squared. All right. Next question here, number 7. What is the formula for perimeter? All right. Well, this one right here that I'm circling, this can't be, all right, because 3 plus 3 equals 6, and this shape only has 4 sides. If I did this one, just length plus width, I would only have these 2 sides. I need all 4, which is y is going to be our middle equation. And so if we set that up as 2 times 24 plus 2 times 132, we're going to get 48 plus 264. And when we add these two up, we're going to get 312 centimeters. All right, because we have to label our answers. So these are the correct answers. Again, at any point, pause this video in order to see what the correct answer / shape is. And if you have any questions, feel free to message me. All right, I hope that this helps. Have a great